Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 21 of our 30-day LeetCode challenge, and the problem which has been given to us today is the leftmost column with at least a 1. I believe this problem is not there on LeetCode, so this is a fairly new problem, and apparently this problem is also an interactive problem. Again, if you want to try solving this problem on your own, feel free to pause this video and check out the link given in the description below and try solving this problem yourself. So let's just go through the problem description. So we've been given a binary matrix, and a binary matrix means that all the elements are either 0 or 1. For each individual row of the matrix, this row is sorted in a non-decreasing order, so basically an ascending order. Given a row sorted binary matrix, we need to return the leftmost column index with at least a 1 in it, and if such an index does not really exist, then we return a -1. So you can't really access the binary matrix directly, and you may only access the matrix using a binary matrix interface. So you've been given a class which has a bunch of functions, and those are the only functions that you can use. So over here you can see that the binary matrix has a get function which returns the elements of the matrix at index x comma y, which are the arguments that you're going to be passing in, and also a dimensions function which returns two elements, which is n and m, which is basically the matrix n cross n. So submissions making more than 1,000 calls to the binary matrix.get function, which basically gets the values, will be judged as a wrong answer, and any solutions that attempt to circumvent the judge will result in, well, that's okay. Um, there are a few other constraints over here. We don't really need to go through it. Let's just try going through the examples because I feel like this is more like a visual problem, to be honest with you. So you can see over here that you've been given a 2D matrix, and the thing that's going to be your answer, or the column which you actually want to give the answer to, or as a result to the function that you're going to be writing, is the one that's been highlighted in red. So you can see over here that we have a 1 coming over here in this inside this column, so we just go ahead and take that. Pretty straightforward. And then they've given another example over here, which is you have 0, 0 and 0, 1. Now the problem over here is that in the first column you don't really have a 1, so you can't really select it, but you have something in the second column, so you do select it and you display the output as 1. So remember that 1 or 0, whatever the output is coming, that's going to be the column number. Another example where there are no ones, so you return a -1. And this problem, or actually this example, is sort of giving us a better intuition on how we want to solve this problem. So let's say that you have a big, big matrix which has a bunch of rows inside of it. And let's say that instead of just 4 cross 4, let's say that it's 1,000 cross 1,000. And in the first row, the first column itself, if you look at all the go through all the rows and check out all the columns which are at index 0, what you will notice is if there are no zeros, you've basically gone through all your iterations. And since we cannot go through, I mean, we can't really exceed the limit of 1,000 requests on the get function, we need to be more optimal about it. So let's have a look at this problem, for instance. Now, usually the typical approach of whenever you try to solve any problem which has a 2D matrix is basically you try to go from the top left and you go till the bottom right. Now that's usually the convention, but we can see that that sort of throws a problem because, well, we don't really need to iterate through all these guys because you can see in this particular row, you have a bunch of zeros, and at the very end, you have one element which has a 1 inside of it. Again, from the standpoint of making this as optimal as possible, we need to leverage the information that has been given to us. And what's been given to us over here is that this row is always going to be sorted. So we can leverage that. Instead of starting from the top left, we can start with the top right. Now, if we start with the top right, there would only be two conditions that could happen. The first condition would be that you either have a 0, in which case that would mean that none of these guys, anything that's going to be on the left is also going to be a 0. That's a straightforward sorting for you, right? If it's 1, well, in that case, you can check what's going to be the next one and you can go to the next value which is on the left. Now, how do we handle all these things? So we've already talked about one. So whenever we encounter a one, we go on the left. But what happens if you have a zero? Well, in that case, instead of going to the left, of which you can't really because you're just going to encounter another zero and we've already come from right, the only other alternative that we have right now is that we can go down. But that really helps us out a lot. So if we can maintain the result, and inside the result we can maintain like, hey, this was the last column which we had found a 1 on. So all the other previous columns for us don't really make sense. So take this guy for an example. So let's say that somehow we've come in this particular element. Now, we don't really need to go on the right if you're already here because we know that this is going to be the smallest that we've encountered so far. So all we need to go to do is we need to go and check on the left. So we do that, and whenever we encounter zero, we primarily just go down and then we keep on iterating forward and then eventually return the result. So inside the problem statement, you've been given a few hints and they also sort of dictate the same thing. But let's just go ahead and try to solve this problem. So we can just start with a quick thing where we can just say, hey, if this thing has not been given, then you just return a -1. I don't really think that this is a proper base condition because, well, we need to define what a none really is inside a binary matrix argument, but let's just say for now that's okay. Well, other thing that we want to do is we need to get the dimensions, and that's actually going to be important for us. So let's get that. So let's do n comma m and binary matrix, and let's just get all the dimensions. So this is going to return, actually this is going to return m cross n, so let's just change that for convention's sake. Let's just call it m cross n. So m is going to be the number of rows, n is going to be the number of columns. Pretty straightforward. Now what we want to do is we want to have a variable that can just use, that we can use as we sort of moving forward and then eventually return it as the variable that we found so far. So the result is going to contain the minimum column that we have encountered so far. Now what we want to do is we want to start our iteration. Now do remember that the iteration is happening on two indexes because you have a 2D matrix with I and a j, and it's not as simple as you just saying, hey, it's a for loop with a for loop. I mean, you could probably do that, but that's not what we're trying to do. So a better approach over here would just be use a simple while loop and just control everything else, and that just makes it a lot easier for us. So let's just go ahead and instantiate our I and j index. And the ith index is just going to be 0 and the jth index is just going to be the, well, the rightmost column. So basically I and j right now are the top right, is the top right element inside our matrix. Now we run a while loop where the while loop is just going to be while I is less than m and j is greater than equal to 0. Pretty straightforward so far. Now all we need to do over here is that we need to just use the binary matrix and basically call the get function. Now do note over here that this is a binary matrix, so there can only be two conditions. You either encounter a 0 or you encounter a 1. There's no 2, there's no 3, it's just 0 and 1s, right? So what we can do inside this if condition is that we can say that, hey, if a binary matrix returns a 1 at this particular index, well, in that case we can update our result. So that's the first thing that we do. And the second thing that we can do is we can skip over to the left element to that particular value that we presently found the 1 on. So we are on I and j, and the left would be I comma j minus 1. So we can just update j. So let's just do j minus 1. So we've decremented that counter, so that will help us go to the left. And if we encounter a 0, basically we need to go down, right? Because we've already encountered something. If there's already a result, then that's also, if there's not, then that's also okay, because you still need to just go down and keep on going down till you find a 1. Eventually, one of these things are going to come true and they're going to break out of the condition, and you basically have your result. So again, result is being stored, and result is basically capturing the columns, or the minimum column where you encountered a 1. And that's basically it. So Pretty straightforward, not that complicated to be honest with you. Let's just go ahead and run this. I had run this solution before, not realizing that I hadn't hit on the record, but you can see that this has run fine, and let's just go ahead and submit this, and hopefully it should get submitted as well. And awesome, you can see that's been submitted and it's been accepted, and that was it. So this problem is actually really interesting because I believe these sort of problems are really asked a lot in the interviews, because they have a visual component to it, and you can sort of use that. You can use it as a game and just sort of go from forward from there. So that was it for today's video. If you did like this video, do give a like and do subscribe to our channel. We are discussion over here and we would love to have you on board with us. Again, if you have any comments and if you have any suggestions, do leave it in the comment section below and I'll try to get back to you as soon as I can. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.